So let's do some examples. Look at these first problems right here. If you notice, we're integrating constants every single time. So if I look at the first problem, it says find each indefinite integral. What's the indefinite integral, or the integral of 5 with respect to x? So what do I take the derivative of and get the answer 5? Well, we know from directly the integral of a constant is 5x, never forget, plus a constant. We always want to check our answers here, so let's think about it. What's the derivative of 5x? I'm going to stop putting the plus c's because every single time we know the derivative of a constant is 0. The derivative of 5x is 5. That matches our original problem, so I know that's the right answer. Okay, let's try the next one. What's the indefinite integral of -1 dr? I want you to notice that here it's with respect to r. So what would it be? Well, it would be -1 times r plus c, but I do want to simplify that. Never put the -1 in front with multiplication. So the answer would be -r plus c. Remember, -1 times r is just -r. That's the simplified version, and we always need simplified answers. Again, I want to find the derivative with respect to r. And just to let you know, most students would actually miss this problem on the test, even though it's super simple, because they would write an x there. You have to remember it is not an x there, that it has to be an r because it's with respect to r. So take the derivative of -r plus c, you would indeed get -1, which is exactly what the original problem is. It checks out. Let's try the next one. It says find the indefinite integral of 2 with respect to t. Again, this is going to be nice and simple. Just be careful with your variable. Here, because t is my variable, the answer would be 2t plus c. How do we know? Find the derivative with respect to t of 2t. Again, I'm not going to use the plus c because we know the derivative of that is 0. The answer is 2, same thing as the original. I know my problem is right. Let's move on. How would you find the integral of 5x dx? So again, the question is, what do I take the derivative of and get 5x? Well, the beautiful thing is we know we can handle constants just by pulling them out in front. So really what this is 5 times the integral of x dx. Now let's go ahead and use that power rule for solving that integration, noticing that this is the integral of x to the 1 dx. So what's the power rule and constant multiple rule say? It says the 5 stays there. Now let's integrate x to the 1. How do we integrate x to the first power? Well, we would have x to the 1 plus 1, which is actually x to the second power, all over 2. Those two numbers have to match, so it's x squared over 2. The power and the denominator match. If I go ahead and simplify this, this would be, well, there's no real simplification. I'll just write it in a different way. So I'm going to get 5/2 x squared, but never ever forget, plus c. So now I want to check my answer if I find the derivative with respect to x of 5/2 x squared. Again, the derivative of a constant is 0. Well, this would be 5/2 times 2x. Our 2's would simplify, and I'd be left with 5x. Notice that that is the exact same thing as the original problem, which means that answer is correct. Okay, so that's what it says. As in the previous example, it often helps us to rewrite the function integral before we integrate. So what it's doing is saying, look, if you have that constant multiplied times the variable, pull that constant out in front, the first thing we did. Think of it as x raised to the first power. Use that power rule, 1 plus 1 is 2 all over 2, and then never forget your plus c. So let's go ahead and do this. It seems like this is one that I've done on a previous page. It just so happens this is the exact example that they chose to do here. What are you going to do anytime you see x to any power? Well, rewrite it just like we would if we were finding a derivative. What I would say is this is the antiderivative of x to the -2 dx. We want to bring that x to the numerator with a negative power so we can use that power rule. So when I integrate that, again, what it's going to be is x to the, well, it's that power plus 1, which in this case, -2 plus 1 is a -1, all over -1, and then we have our plus c. But we do want to simplify that, so I'm going to go ahead, because it has a negative power, I'm going to bring x to the denominator, and I'm going to write this as -1 over x plus c. Again, that negative could be on top, out front, or on bottom. It doesn't matter where the negative sign is, as long as you have one. So here's my answer to the problem. I always, every single time, want to check my answers. I'm going to take the derivative of, and then I'm going to write this as -1 times x to the -1. That helps me use the power rule. So this would be negative 1 times negative 1x to the negative 2. Negatives are going to cancel. Throw it into the denominator. That's 1 over x squared, which is the same as my original problem. I know that answer is now correct. Let's look at example B, the cube root of x. Just like you would if you were a derivative, change this radical into an exponent. This would be the antiderivative of x to the, well, it's the cube root of x, so that's x to the 1/3 power with respect to x. How do I find the antiderivative of x to the 1/3? Well, I use the power rule for integration, which says what I want to do is x to the 1/3 plus 1 all over that exact same number, 1/3 plus 1. Never forget the plus c. Well, 1/3 plus 1 is 4/3, so this would be x to the 4/3 all over 4/3. But now I have a compound fraction because I have a fraction over a fraction. So what do? And essentially, I multiply by the reciprocal of the fraction on bottom. Multiplying by the reciprocal of the fraction on bottom would be 3/4 times x to the 4/3, and then don't forget that plus c. So this is what I have as my answer, 3/4 times x to the 4/3 plus c. Of course, I could write this back in radical notation if I really wanted to. At this point in time in this semester, I do not care about writing it in radical notation. You might need to write it back in radical notation for WebAssign or whatever online homework system you're using, but this is going to be good enough for my class. I am okay with you leaving your answer in exponential notation instead of radical notation. We do, however, want to check our answer, so I'm going to do the derivative with respect to x of 3/4 x to the 4/3. I'm going to use my power rule. That's going to be 3/4 times, drop the power, 4/3 x to the power minus 1. 4/3 minus 1 is 1/3. Notice the 3/4 and the 4/3 simplify, and I'm left with x to the 1/3. I go back and look at my original problem, which is the cube root of x, which is x to the 1/3. That means my answer is correct. Example 5a says find the integral of x plus 4 dx. Again, this is saying what function do I take the derivative of and get x plus 4? So how am I going to do this? Well, the first thing I want to do is separate this as two separate integrals, the integral of x dx plus the integral of 4 dx. I want to think of this as two separate integrals. Well, what's the integral of x dx? Again, I'm thinking of this really as x to the 1. Using the power rule, I'm going to increase the power, so this would be x squared, but then I need to divide by that exact same number. And the integral of any constant, what do I take the derivative of to get 4? The integral of any constant no longer is 0. The integral is x added on to that number. So the integral would be 4x, but then never forget your trusty old plus c that you have to remember every single time. So my guess is the answer is x squared over 2, which is the same thing as 1/2 x squared, plus 4x plus c. Let's see if we're right. What's the derivative with respect to x of 1/2 x squared plus 4x? Well, if I take the derivative of 1/2 x squared, it would be 1/2 times 2x raised to the first power. And the derivative of, sorry, that's a 4x. The derivative of 4x is 4. The 2 and the 1/2 cancel, and I'd end up with x plus 4. X plus 4 is the original function. So if I look at it, the original question said, what function do I take the derivative of to get x plus 4? The answer is x squared over 2 plus 4x plus any constant. So if I take the derivative of x squared over 2 plus 4x plus any constant, I will get x plus 4, which we verified. So we have found the antiderivative of x plus 4. Let's try this one right here. You're going to get really good at polynomials, just like you are with taking derivatives. You'll get really good with finding the antiderivatives of polynomials. So I'm going to break this down one more time and look at this as three separate integrals. I expect you guys to get a little better, a little faster, and showing a little less work as you get more proficient with these. So this would be 3 times the integral of x to the 4th with respect to x, minus 5 times the integral of x squared with respect to x, plus the integral of x with respect to x. Again, I'm separating all addition and subtraction. I'm pulling out any constants out in front. This is going to be 3. I'm going to use the power rule every single time. The integral of x to the 4th is x to the 1 with the power plus 1, which would be 5, but I need to divide by that exact same number. Minus 5 times the integral of x squared using the power rule. 2 plus 1 is 3, so this would be x cubed over 3, plus the integral of x, that's x to the first power, use the power rule and add 1. This would be x to the 2 all over 2, so that's 1 higher power. Never forget your trusty old plus c. Let's just write this a little cleaner, simplify if you can. I'm going to write it as 3/5 x to the 5th minus 5/3 x to the 3rd plus 1/2 x squared plus c. No, you didn't have to write it that way. That's just how I chose to write it. This is my guess as to what the antiderivative of 3x to the 4th minus 5x squared plus x with respect to x is. How do I know it's right? Well, let's find the derivative of that. If I take the derivative of that entire thing, what would I have? Well, I'd have 3/5 times derivative of x to the 5th is 5x to the 4th. Minus 5/3 times, well, the derivative of x cubed is 3x squared. Plus 1/2 times, well, the derivative of x squared is 2x. And the derivative of a constant is 0. Notice my 5 simplify. I'm going to end up with 3x to the 4th in the first term. My 3 simplify. I'm going to end up with minus 5x squared for the second term. My 2 simplify, and I end up with plus x in the last term. Notice my answer here, when I differentiated my answer, I guess I should say, is the exact same thing as the original problem. That means my answer is correct. So I've checked my own work at this point in time. I could grade my own work. So again, the original problem said, what's the indefinite integral of 3x to the 4th minus 5x squared plus x? What function do I take the derivative of and get 3x to the 4th minus 5x squared plus x? And I'm saying the answer is 3/5 x to the 5th minus 5/3 x cubed plus 1/2 x squared plus c. In other words, if I take the derivative of 3/5 x to the 5th minus 5/3 x cubed plus 1/2 x squared plus c, I will get the original problem.